Welcome back. This module is all about high-performance data loading. Populating and maintaining your Redshift cluster with fresh data is going to be a critical aspect, and is a critical aspect of most approaches to data warehousing. I say most, really I should say all. This is an area where you can have a drastic effect on overall performance, both in a positive and a negative way. So there are a couple options for loading data into your Redshift cluster. If you have any experience with Redshift, you should know by now that using the SQL language is typically the slowest. However, there are instances when you may still use a SQL language approach. We'll go over some of the guidelines that you should follow when inserting and updating data directly with the SQL language. Namely, we're going to be focusing on a variation of the create table statement and then an approach known as insert into select. Leveraging this method, you'll find that you have inserts that are as fast as the bulk load approach. They do have some constraints, however. For the vast majority of the loading that you do, the copy command is going to be true best practice. We've covered many of the aspects of the copy command in that first course. However, keep in mind, throwing down a copy statement doesn't automatically mean you're getting the absolute best performance available to you. There are a number of options and switches that you should understand in order to control your approach. So much of this module will be going over each of these options from the perspective of performance. This will include options such as source file compression, setting up your manifest files, and ensuring that your data loads can take advantage of parallelism. Again, anytime you can take advantage of the massively parallel potential of Amazon Redshift, the performance of that related operation is going to really shine. Now, when talking about loading data, it's not just the act of that load that concerns us for overall performance. There are additional configurations and techniques for data loading that can have a lasting impact on total system efficiency and performance long term. In other words, a simple data load operation can have a very lasting effect on performance of your Redshift cluster long after that load has finished. This is where we're going to talk about something I hinted to in the previous module, one of the very best approaches to selecting your column level compression approach. This occurs during that very first load of data and is built into the copy command. Miss the opportunity there, and getting compression right will become much more difficult down the road. After that, we'll close up this module with a couple other approaches to planning ahead before we move on to the next module.